Hello viewers. So we have this question under chemical kinetics that says the gas phase decomposition of N₂O₅ was found to follow first order rate law and the half-life was determined as 45 seconds. Calculate the rate constant for this reaction and how much time is required for this reaction to be 47.3% complete. So we are looking for the rate constant for this reaction, and then we'll also look at the time it will require this reaction to be 47.3% complete. So how do we find that? All right, let's start with the rate constant. Now, the half-life equation for first order is given as T half, where T half is half-life, is equal to natural log of 2 divided by the rate constant, which is K. We are given the half-life and we are looking for the rate constant. We are given this T half and we are looking for K. In this case, we'll make K the subject of the formula. So making K the subject, what we'll basically get is K is equal to natural log of 2 divided by our half-life in this case. Replacing with what we have here, our K will be equal to natural log of 2. Remember, we are given half-life to be 45 seconds. So this will divide by 45 seconds. And this will give us an answer that is, according to my calculator here, I'm getting a 0.0154 rounded off to 4 decimal places. Yes, so our unit here is per second, so it's s to minus 1. Yes, so yeah, this is our rate constant value, 0.0154 per second. As simple as that. So that's the first part. Let's look at the second part. So let me get rid of this. Now the second part is talking about how much time is required for the reaction to be 47.3% complete. How do we find that? The first step is to determine how much of the initial amount will remain. So the initial amount is considered to be 100%. So we have 100% at first before anything is used. And then we are told to say 47.3% is used. So we'll say minus 47.3%. So 100 minus 47.3%, this is giving me a 52.7% according to my calculator here. So it implies to say when 47.3% is completed, what will remain from the initial amount is 52.7%. Now, we need to take it to standard values. So 100% is 1. When you divide 100% by 100%, you get a 1. In order to move from percentage to standard value, we divide by 100. So when you divide 52.7% by 100, what we are getting is 0.527. So these are the standard values we're going to use in determining the time it will take for the reaction to be 47.3%. So let's go ahead and do that. The formula we need here is T, we are looking for time, is equal to 2.303, like this, over K, and this will multiply by log of the initial amount on top there. In this case, we're representing it as concentration divided by the final amount, or that which will remain, like that. So this is the formula we need. You can also use this formula. You are to liberate also to use this one that says T is equal to 1 over K, and this one uses natural logarithm. It will be natural log of A initial on top there divided by A final down here. So any of those two formulas will still help you. In this case, I'm using the first one. So let's go ahead and now replace. So what we have there is we'll have our T is equal to 2.303 divided by the value of k that we determined earlier on is 0.0154. So we're using it here. Then this is multiplying by log of. We are saying the initial amount is 1, and this will divide by the final amount is 0.527. Yes. So this is what we have here. So this will give us t is equal to, now we'll have 2.303. Now when we say log of 1 divided by 0.527, what we are getting is 0. So this will multiply by 0.278, rounded off to 3 decimal places. And then this whole thing is divided by 0.0154. Yes. So remember, this value here is when you say 1 divided by 0.527, then get the log of that. We're getting this value. So when you reach here, all we have to do is just punch our calculators. Taking it on this side, let me just get rid of this part so that we use it. All right. So taking it here, what we are going to find is t on top there. When you multiply 2.303 by 0.278, what we are getting is 0.640, like that. And this will divide by still our 0.0154. And our t finally will be equal to, what I'm getting is a 41.6 seconds. So it will take 41.6 seconds for 47.3% to complete. So this is how we go about this type of questions. If you found this to be helpful, subscribe to our channel, like, comment, and share so that we can make more videos like this.